Hey, what's up everybody? It's Mr. Boylan. Let's do some awesome limiting reactant problems. If you take a look at question number 1, we are told that silicon dioxide is usually quite unreactive, aren't we all? But reacts readily with hydrogen fluoride according to the following balanced equation. If 2.0 moles of HF are exposed to 4.5 moles of SiO2, which is the limiting reactant? Alright, now there are a couple different ways to solve limiting reactant problems. Probably the easiest is to pick a single product. In this case, we'll pick SiF4, and think about how much of that product each of our reactants would make. Let's start with the 2.0 moles of HF. If all 2.0 moles of HF were to react, how much SiF4 would we make? Well, according to the stoichiometry in our balanced chemical equation, the relationship between HF and SiF4 is a 4-to-1 relationship. And so if I solve this quick dimensional analysis problem, 2 times 1 divided by 4, who needs a calculator, I get 0.5 moles of SiF4 produced. But let's do a similar calculation, but this time we'll look at how much SiF4 is produced from 4.5 moles of SiO2. I take my 4.5 moles SiO2, I set up a quick conversion factor here, again comparing it to that same product of SiF4. Now I'm comparing the relationship between these two things, and according to my balanced chemical equation, we've got a 1-to-1 stoichiometric relationship. A quick calculation results in 4.5 moles of SiF4 produced upon the reaction of 4.5 moles of SiO2. So the question now becomes, well, which of these two reactants is limiting? Look at the amount of your product produced in each example calculation. It should be easy to recognize that our HF is limiting the production of SiF4, because even though we have 2 moles of HF, it's only going to make 0.5 moles of SiF4, which is less than the amount that 4.5 moles of SiO2 could produce if all of it reacted. So it is our HF that is our limiting reactant. It is limiting how much of our product we can make.